Pessoal, boa noite, boa noite. Chamar aqui o professor Soheil. Aguardando ele aqui. Boa noite a todos e a todas. Esperando pelo professor, esperando ele aceitar aí. Waiting. Waiting for Soheil, Mansouri. Ok, vai aparecer agora. Hi there!
Hello, Ewerton. How are you?
Hello, I'm fine, and you? What's
I'm also
going on
fine.
in Copenhagen?
It's going all right. Surviving.
Me too.
I am very much new to this type of, platform. I've been an Instagrammer for a long time, just for my personal thing, but I've never done this before.
Yeah,
So,
I don't like Instagram at all.
oh,
I
you
don't
don't
like
like
this kind of
Instagram?
check. I don't like.
All right.
In which part of the world are you now? Are you keeping your great travel?
No. I'm stuck in Denmark. But we've been having actually a very nice summer here. So the past 2 3 weeks have been so sunny and warm. So we've been just enjoying. So it's been pretty good.
Yeah, I stuck in Denmark. What a nightmare.
No.
What a
So
nightmare.
it's also fine being home.
Okay. Let's wait a couple of minutes to the guys, to the public coming to the chat, okay?
Yeah.
So tell me, what are you doing in terms of research? I'm working a lot here, more than ever, because of this pandemic issue.
Well,
I don't know about you, but me, my goodness, full of work.
I think the working style has been changing quite significantly. In a way that this transition moving from a lot of face-to-face activities to having basically being home, trying to keeping up with everything virtually.
Yeah,
I think it's been at the beginning, I would say it was a challenge, especially in terms of teaching the courses with the students and so on. Um, but I think slowly we're adapting to it. Another chat that I had with another fellow a while ago, one of the things that I also mentioned is that, this transition is a lot challenging, but at the same time, it also opens doors for many different opportunities that now we have as day by day we are learning more about this whole virus, its mechanisms, and so on. Plenty of research is being carried out. At the same time, we are also having this opportunity to learn about different aspects of our daily life. So,
yeah,
so I would say it's been pretty much something that opens doors to learn new things. Uh,
yeah,
I think us as uh, as people, we should not just see it as a challenge. Every single challenge opens doors for new
yeah,
things to learn, and then that learning, maybe we have to cherish. Maybe it is
right.
a way to keep positive. So
Yeah, yes, of course. I'm learning to use my time wisely, because before the pandemic, I spent almost 4 hours a day, 2 hours to go to work, and 2 hours to go back. So 4 hours I spent. So these 4 hours I'm using to walk outside and work more and
Yeah,
something like that. Yeah.
I mean that's good. Netflix, more time for Netflix.
No time for Netflix at all. Time for work, right? And yeah, that's it. Okay, let's get started. Okay, we have
Yeah,
several people there. That's okay.
you're.
Let me see. Yeah, I make a formal introduction of you. Okay, so to the public to know more about you. Christian is saying walking. Yeah, walking outside. Because where I live here, I can go walking the streets and so
Yeah, I think in Brazil.
losing a little bit of weight.
Yeah, last time that I was in Brazil, it was quite warm. So I mean, walking also outside with that level of
It's
humidity
not a
would
good
not
idea
be.
in Denmark.
It's
Yeah. Yeah.
now in Brazil. I mean, Denmark, it's
Yeah.
windy. I mean, it's
Just indoor.
okay, maybe. Yeah.
Yeah. Yeah. It's impossible.
All right.
Yeah.
Right.
Okay. Okay, everyone. I will speak in Portuguese now to the public, okay? You guys, pessoal, essa live ela vai ser em inglês, né? Mas apesar dela ser em inglês, vocês podem fazer as perguntas em português e eu vou procurar traduzir as perguntas para o professor Soheil, okay? So, Dr. Soheil is an assistant professor in the Department of Chemical and Biochemical Engineering at the Technical University of Denmark, DTU, since February 2018, and affiliate faculty at Sino-Danish Center for Education and Research in Beijing, China. He received his PhD in 2016 and Master of Science degree in 2013 in Chemical and Biochemical Engineering, both from DTU. His current line research is primarily focused on developing systematic methods and tools for synthesis, design, control, and optimization of chemical and biopharmaceutical processes, and an aim to achieve more intensified, sustainable production and consumption. He is a senior member of the American Institute of Chemical Engineers, AICHE, and representative of Denmark to Computer-Aided Process Engineering, CAPE, and the working party of European Federation of Chemical Engineers, EFCE. So, Professor Soheil, I'm so glad to have you here. Thank you so much to accept our invitation and to be with us in this live chat. So I'll get started asking you, who is Professor Soheil Mansouri? Where are you from? What's your graduation, post-graduation? Where do you live? Where you've been living all these years? I know you lived in US for some years, right? So introduce yourself.
Yeah, thanks, Ewerton, for the nice introduction. Yeah, if I want to take it very casual, I'm an Iranian. My parents are Iranians. I was born in Iran. I received my primary education in Iran. I finished my high school in the US. I lived in Syria, Mexico, Malaysia, Denmark, USA, in different capacities during training, internships, living, educating myself, and now being an educator in Denmark and so on. So I've been pretty much taking a passage in my life. I mean, moving far and beyond, a lot for different purposes. So my background is chemical engineering. I received my bachelor's and master's in chemical engineering, and I did my PhD in process systems engineering here at DTU. And then I I did a rather short period of postdoc, about a year, and then afterwards I took up a position as an assistant professor here at TTU. So basically, as you also mentioned at the moment, my research is focused on looking at the dynamics of the complex multi-scale, multi-dimensional systems. And also I have a lot of interest in education, in educational agility, looking at agile computational technologies and approaches, and I try to bring more understanding across skills for various processes and systems, predominantly in chemical engineering, biomanufacturing, and pharmaceuticals. So basically, when I say multi-dimensional, I mean that a lot of the processes and systems and the products that we have in our society, the services, they are operating across different scales. I mean, a lot of our products, I mean, they inherit their properties from what happens at the molecular scale. And then we go across the scales to actually produce them in micro scales, in larger scale productions. And finally, there are going to be products in different forms or services at hands of the population and the consumers. So in my research, I am trying to pretty much find first the bottlenecks. Where are the bottlenecks when we talk about issues like sustainability, like profitability, like performance and efficiency? First of all, where is the bottlenecks? Where is this bottleneck located across these different scales, like our own human body? Or I mean, one simple example is that when we feel a pain in our body, that pain may be caused from another reaction, another phenomenon somewhere else in our body, and it is just felt elsewhere. So often we just don't just open our own body where we feel the pain. We try to figure out where the pain comes from. In process systems and complex process systems, it's also a similar story. Often in the society or in different scales, we are feeling a pain, but we need to actually very well understand what are the root causes of that pain, so we can actually properly and efficiently try to tackle such pains. So and when I talk about different dimensions, pretty much I mean a lot of almost all interactions, all systems are defined within our human society, and its context. So in principle, the process and systems have different dimensions across economics, society, consumers, technology itself, and so on. So there needs to be also a sufficient and coherent understanding of the interconnections between different scales of progression and complexity of the processes and systems, and the interplay of these various basically scales with different dimensions. So that is pretty much myself in a nutshell. Personally, I have a little dog. I mean, we pretty much have a nice coexistence together. I mean, well, the past few months actually, and that is actually quite interesting. I mean, the past few months that I've been working pretty much from home, my dog has been also spending enormous amounts of time with me. So whereas in the past, I mean, he was pretty much used to stay on his own at home. But now these days, I mean, now this is the whole thing about this pandemic and the transition. If we want to go back to what we started our conversation with, that now the dog actually doesn't want to be home alone anymore. So it is a
Yeah,
challenge. I mean, now in Denmark, a lot of restrictions are lifted. We are allowed to go back to work, business as usual. But now I have the challenge with my dog.
yeah,
You know,
yeah. It's tough.
and
Yeah,
and so this is a dimension. So this is actually a dimension. So dimensions also in the technological landscape can change as our attitudes and habits basically change. So we need
yeah,
new and more informed ways of addressing the challenges. And one of the lessons learned um, from this period of crisis is that a lot of the systems that we are dealing with, they're not really equipped uh, with tools or approaches that they can accommodate such transitions.
yeah, yeah.
You know,
Need to
so
adapt. Yeah,
yeah, so
yeah.
that's pretty much me. Yeah.
Oh, nice, nice. Yeah, you said something interesting about process systems, because process systems engineering goes beyond chemical engineering, right? System can be anything.
Hmm.
Anything can be a system. You can see with the eye of a system uh, elements interconnected, human body, a chemical process, chemical equipment, and everything can be interpreted as a system, right? Uh, in this way of think of a system, the idea of a system. Uh,
Yeah, but I was actually
so
in high school. When I was actually in high school, once I read a book from a Chinese philosopher. I barely remember the name of the guy, but um, one thing that I understood from that text, when I'm one of the messages from the text was that it's actually our universe is basically based on chaos. So basically, it is as our human brain that we are trying to systematizing
mhm,
and finding patterns within this chaotic landscape. So a lot of times systems also systems come actually just as something to be put in front of chaos, you know.
yeah,
So system actually finds meaning when we have have chaos and basically by having a
it's the
system.
influence of one thing in another, one thing
Exactly. So
influencing the behavior of another. Yeah,
exactly. So now, as we try to look at more chaotic landscapes and more interactions and more interconnections, basically managing this complexity and finding those patterns becomes more and more difficult.
yeah,
So in principle, process systems engineering is use of is the use of the computers and computational tools to solve the algorithms or to solve the ways that we envisage to manage this complexity, to understand this complexity, because from a point onward that this complexity goes beyond our human brain computational capacity, uh, basically then we need to use the power of computers to actually solve those problems, to find the optimum
yeah,
pattern. There could
yeah.
be many patterns that
Right, right.
will lead to the same end.
Hmm.
But there's always the question, which one is the best way to take? And that's also pretty much, I mean, if we want to look at it quite philosophically, that's also the way that in our life, we try to optimize on a daily basis with our decisions. Decision making is an optimization. So in the process of decision making, even on our daily life, we have plenty of choices. Then it is to our own life objectives, to the objectives that we can perceive, that we want to find the best pattern,
Every day.
the best decision to make.
Yeah.
Now imagine if there was a way more powerful system than your brain that could actually analyze all these systems, and you could actually have such well-defined objective.
It is called transhumanism.
Exactly.
Yeah.
Something like that. So no wonder we may become cyborgs in future. But the point was that it is something that us as human beings are practicing on a daily basis. This process of decision making. I mean, there is not always a single decision. There are always a multitude of decisions. That basically we need to pick the best that serves our objective. So in complex systems, it's also a similar thing, that we are trying to find the best ways to serve our objectives. Now, sometimes it is productivity, sometimes it is more production, sometimes it is more profit, sometimes it is a more sustainable a way of doing something. But this element of more and more and more, or better or better or better, is actually the thing that we are trying to actually tackle in systems engineering, to find answers, to be able to find the best solution out of more and more alternatives.
Professor, talking about process intensification, could you define what is process intensification and why it's so important nowadays? And when you got interested in process intensification area?
Well, if you look at the open literature, there are a number of definitions for process intensification, but the way that I would like to use a definition for a process intensification is when we can actually come up with multifunctional unit operations that are more sustainable. That they're not only actually increasing the productivity or profitability, but also they're more sustainable. In my opinion, if an intensified process is not more sustainable, it is not. We haven't done much. Now, what is that sustainability and what criteria we want to take into account to define that sustainability is also another thing that we can sit down and discuss, and people are discussing that in open literature a lot. But in a nutshell, process intensification is that you can actually combine a set of phenomena or tasks or unit operations towards an enhanced operation that you can fulfill your objectives in a single unit operation. In another way, an intensified process from a size point of view should reduce the size of your operation, right? So one element of process intensification is size, as the word implies. The other element of process intensification is profitability, and another element in process intensification is sustainability. So a process that is multifunctional, smaller in size than an existing process, can generate more value and is more sustainable. Then if it has these four characteristics, then it can be an intensified unit operation.
Very, very nice. Very nice. I think it seems it's really, really tough to achieve multiple criteria object, right? because, for example, my next question, is it possible to enhance mass, heat, momentum, transfer, decreasing equipment volume, as you said, and increasing at the same time, increasing efficiency and while ensuring feasibility, operability, controllability at the same time, and at the same time safety? Is it
Well,
possible to intensify a
I,
process and at the same time achieve all these goals?
uh, I believe so. Uh, I believe so because if you refer to thermodynamics, you know, if you can basically correlate all these things that you said, for example, to a thermodynamic property like the minimum Gibbs free energy of the system, and then you go actually to the minimum Gibbs free energy of your system, and then you correlate all these design and control objectives to that point, in principle, you can achieve it.
Yeah, sure, sure.
I mean,
And
I mean, I mean, basically, maybe we should. It's not the place to actually we discuss the detailed science, but if I want to be very, very simple, I would say we need to find the key law of thermodynamic or nature that we can correlate this to. Once we find that, and we find that correlation, these all things are derivatives from
right,
those fundamentals. If we cannot
yeah,
do it at the moment, or we can partially do it at the moment, it's simply because we haven't yet found the correlation or the clue about them. But
yeah.
hypothetically speaking, I would say yes, possibly yes. I don't know.
Mm-hmm. And do you know what is the today? What is the state of the art in terms of methodologies and technologies to intensify processes?
A lot of people, many people in the field are working on different aspects of process intensification, all the way from conceptual level process intensification to miniaturized reactors or microfluidics or different or quantum dots or different approaches that you could basically classify them as a process intensification approaches. So I cannot say what is the best approach or what should you use just now, right? But if I want
Mhm.
to give a hint, I think it is very important that one first understands very well
Yeah,
what is an intensified process. Once you understand what is process intensification, then you can actually, based on your needs, you can actually start looking into different methodologies. My own favorite approach is that if we can use some of the already developed process intensification methodologies, like the phenomena-based process intensification or process intensification based on process building blocks and so on, as model-based tools to provide input to basically the experimentalists who want to actually now look into specific applications of process intensification. That is going to be very exciting. So because through some of these model-based process intensification methodologies, you can pretty much arrive into to process intensified alternatives that do not exist at the moment. So you can
hmm,
actually, for a given task, generate uh, a large number of different process intensification alternative, but then still the question remains, which one should I then invest in developing?
Yeah.
You know, I think one of the challenges with some of these approaches is the issue of investment. I mean, how am I going to find the application? Who is going to fund it? How am I going to convince people that this is going to be actually beneficial? Because up to a certain point, we can hope that we can do things as an academic exercise, and I believe it should be the role of the academicians and universities and research institutes to basically do these things. In academia, we're not necessarily supposed to do things that should turn into a business. But I think it is also important that we can also internally optimize our resources. How do we want to direct our research and look into different approaches? What is going to be the benefit? So the more that we can use the model-based approaches and methodologies to reduce this extent of try and error activity, maybe, that many of them actually remain an academic exercise. We should do those academic exercises. But if we can actually do it more efficiently, that we can also use the resources to develop and go towards the technologies and approaches and unit operations that can much faster go toward implementation, that's going to be more beneficial. The other aspect is that we need to educate our students. I mean, the prime goal of universities is education. And there should be an effort in developing and embedding process intensification into the chemical engineering curriculum. So students from early on in their education get familiar with process intensification concepts. Where is process intensification, the examples of process intensification, and so on. So this is also partly something that is on our shoulders as teachers in universities, to bring this into the existing curriculum and to start teaching our students, because it is going to be them who should then have the mindset to then bring these intensified processes to the industries. Those are going to be the people who are going to advance in the industry. They're going to drive the industry. So they need to have the mindset. They need to have a very good understanding of what is process intensification. So once the technology is developed, there is also the mindset within the enterprises to take it. If the mindset is not there, it's going to be very hard to convince, let's say, a company to give up on its existing process, make a massive investment on further developing an intensified concept, right? It's a lot of risk for a stakeholder to take.
Sure. Yeah. Christiane is asking, do you believe what is the best software for process intensification? She want to know what is the best one.
Well, in principle, before, I do not know a software, but in principle, if you can devise a systematic methodology, there are I don't know a commercial software. There are colleagues within the community who are developing softwares for some industrial applications and so on. But basically, in principle, if there are systematic methodologies that have been developed for process intensification, and of course, if they are automated, there are going to be softwares. I mean,
Yeah,
before you have a software, you need to have a methodology, and before you have a you need to have a methodology, right? And then you need to embed that single methodology or a class of methodologies that you're managing the information flow between them in a systematic framework, and then create the workflow out of it. Once you have the workflow out of it, then you can implement the software.
yeah,
So
yeah,
so that mindset is more important than software. So once you have
yeah,
that workflow in place, I mean, anybody can make that software.
yeah, yeah. In addition to her question, uh, it's a great opportunity to companies like Aspen Tech and other, and to anyone who wants to develop a new kind of software to intensify, right? It's a new market, a new business. You agree?
Well, I think if it is on the conceptual level,
Yeah. Conceptual, yeah.
if it is at the conceptual level, I would say the existing methodologies for they cannot guarantee or provide operational information for an intensified unit operation that does not exist. So often, unless you do not actually get into the lab and put that thing together and basically start doing experiments, it's going to be very hard to verify. Of course,
Yeah.
these methodologies have basically rules and laws and other things embedded within them to guarantee some degree of feasibility. But unless we do not test it out, it's not going to be even at TRL1,
Yeah.
right?
Yeah.
So,
Right.
so the question is that, okay, if I intensify my process today with the best software in the world, and it gives me a solution that does not exist off the shelf,
Auto-validate,
who,
yeah.
no, imagine the validation, everything is also possible. First, how much does it going to cost me to do all these things? Second of all, does it worth all that investment? Or is it is still better that I actually go and buy the solution that is available off the shelf, the traditional solution, non-intensified solution? The question with a lot of process intensification solutions is the issue of scalability. If somebody who is going to first invest in it, and basically, is it going to be actually for one single application, or is it going to have many applications? If you look at, for example, one of the most successful examples of process intensification is reactive distillation, right? So it has, or divided wall distillation cooling, right? Right. So if you look at those examples, I mean, they have been pretty much scalable solutions. At some point, they were developed. Then
Microreactors, yeah.
exactly, and so on. But if you want to look into the literature, there are maybe many more examples than these few.
Yeah.
But why aren't those examples implemented?
Good question.
I mean, it's not the question that they don't work. It's the question that how much somebody is willing to actually spend in developing them, and how can an investor get back their money?
Yeah. Yeah. Sure. Yeah, and could you explain, because we have process intensification, right? And we also have other terminologies in process system engineering, such as process synthesis and process integration, process optimization. You know, all these areas are interconnected and serves process intensification, right? All
Mm-hmm.
these abilities and methodologies optimization, process synthesis, and integration are available to intensify a certain process, right?
I didn't get the question actually, Ewerton.
Yeah.
Could you?
What's the relation between these different kinds of fields? Process optimization, process synthesis, and process integration. What's the difference between these kind of methods in relation to process intensification? Or what these kind of methods are
All right, I think then we need a.
related to
Yeah, I
process
think we need
intensification?
a classification. So if I want to to say where is process synthesis, basically process synthesis is that given a set of raw material and a product, right, find the optimum pathway to produce that. So there could be many different ways to produce that, intensified or non-intensified, right?
Yeah.
So process synthesis is basically figuring out where is going to be the optimum route given an objective function. Now that objective function could be an economic a single objective economic function, or it could be a multi-objective function that takes into account other factors like environment or society or safety or the other things into account, or uncertainty or anything else um, um, uh, within it, right? Once you have found that actually optimum route, then basically you will carry out the process design. So now when you talk about process optimization, so there is process optimization in process synthesis, because often you solve an optimum, you have an objective function. Now you formulate your problem. Either you formulate it as a mathematical programming problem like a MILP or an MINLP or NLP or whatever. Basically, then you solve that set based on that given objective function. That's a process. That's an optimization problem that you're solving, right? Once you have a process design, again, you can do a process optimization. So optimization on any system, given the fact that you have an understanding of that system and where you want to go with that system in terms of optimality, I mean, could be at any stage, right?
Yeah. Right.
But then when you have the process design, once you have a process design, then one of the actually key drivers for process intensification is that do you have a first? You need to start thinking about this question. Do you have a bottleneck in this process? So if you have a bottleneck in this process, for example, if you have a distillation column that is very energy intensive and a reactor that has a very it's an equilibrium reaction, and basically you cannot go beyond equilibrium with it, right? So that's going to be a bottleneck. So the solution to that could be a reactive distillation. So in a reactive distillation, you combine the reactor and the distillation. Basically, you combine the reaction and separation, and by simultaneous removal of products from the reactants, you start shifting the equilibrium, right? So in this way, you improve your process at a phenomenal level by improving, by helping the equilibrium and shifting it towards the product. I mean, you reduce the size. Your process hopefully is more sustainable, right? You will have to consume less energy, and you have shrunk the size of the process as well into a single unit operation. So that is the classification. I mean, just a little bit after midnight in Denmark that I could give.
Yeah. Now, there is a student here asking, what's your opinion, process intensification concepts and methodology? Why? why process intensification concepts and methodology aren't widely known by the investors and engineers nowadays?
Well, I
I,
think
I
as we
think
just
I think you answer. Yeah,
I think as we just discussed it, it has twofold.
yeah, yeah,
Um, if it is not, if the claim, I first of all do not necessarily agree it is not known within by the engineers. I think many of the engineers um, are familiar with a lot of the process intensification developments. Maybe sometimes they don't know what to call it. But on the other hand, I would also say that part of it goes back to our education, that we need to actually include more and more process intensification concepts within the core chemical engineering education. Why it is
yeah,
not, I cannot speak for an investor, because I would say for an investor, if somebody can answer the issues of scalability, who is going to be the end user, where's the market, and what is the return of investment, I think if somebody can answer these questions, well, the investment could be actually plausible. Um,
yeah,
so I think when it comes to process intensification, as we discussed, there are examples that are widely used now, like reactive distillation or divided wall columns or microreactors and so on. But some other examples have not really made it to full-scale implementation for various reasons. It could be technological, it could be economic, it could be scalability. Yeah.
yeah. Christian is asking, which area of chemical engineering would change the most when it comes to process intensification? She wants it. Okay, you
I
stop.
think,
Pause.
hello?
Okay, you're back. You're back. Yeah. Okay, you go back. You went back. Yeah. Okay.
Yeah. So I think, I'm not sure if I'm understanding the question correctly. Are you asking that in which industry process intensification
I
is
think she.
going to have the most influence? Actually, that's a very difficult question for me to answer at the moment, because, I mean, if I want to go back to my classifications, well, you need to have a process. If you can identify what are the bottlenecks within this process, and then you come up with a solution that can actually substantially improve that process, that economics are all of a sudden in place, that you can basically justify an investment
Yeah. Yeah.
for that
I
change
think.
in your process. It could be anywhere across chemical engineering. So I
Yeah.
think, again, identifying the process bottlenecks and understanding what are the root causes of those bottlenecks, then tackling those root causes through process intensification, that would be the thing. So if you ask me which area of chemical engineering, I can, I don't know. To be honest, I cannot claim now. But where I can say that if somebody follows these steps, in principle, it should be possible to first develop intensified processes. Second of all, work towards implementing uh,
Yeah.
in process intensification as alternative to existing some of the existing more sustainable solutions.
Yeah. I think she meant to in chemical process in a chemical process plant, which equipment would provide a great return on investment, right? If this equipment would be intensified, you know. for example, a distillation tower.
Well, there are examples. There are plenty of examples on where distillation trains. I mean, the most famous example is the methyl acetate production by the Tennessee Eastman process that they shown that basically the whole plant can be accumulated into a single reactive distillation column, right?
Yeah. Yeah.
So the thing is that, I mean, it's a very difficult question for me to answer without proper analysis.
Yeah.
But what I can say is that as long as you have the right tools to identify the bottlenecks in a process in terms of sustainability, economics, waste, environment, and so on, right? And you can realize where the bottlenecks, where the key contributors to these process performance indicators are in your process, and what part of your process is identified as a bottleneck, then that bottleneck would be the target for process intensification. Yeah. So now what would be that intensified process? I don't know, again, right?
Yeah.
But then we can use these model-based approaches or experimental approaches, or the existing know-how knowledge to basically see how we can intensify or address that bottleneck, to remove it, to make it more efficient with process intensification.
Yeah. Let me make you a provocation here. Okay. What do you think? The equilibrium, transport, and kinetic properties of functional materials, for example, solvents, catalysts, absorbents, influence intensification, right? All these properties influence intensification. Furthermore, a process can be intensified using a single material like that, with multiple functionalities, or using multiple materials with a single functionality. My question is, how a combination of different materials could intensify the process level performance? What do you think about that? You know, how this combination of different materials could improve the efficiency and the performance of the intensified process?
Well, if you can actually, if the problem that you're facing at the unit operation level is actually having its bottleneck at the atomic level and molecular level, and then you understand the interconnection between the molecular level interactions and properties, then of course you can address it. I mean, but the whole key is in that understanding.
Yeah.
And then do we have the right tools and knowledge?
Yeah.
To make that understanding.
Yeah. Okay. And how about in terms of retrofit? What do you think? Is it possible to use process intensification to implement an intensified equipment, and make some kind of merge between the existing process with another new intensified process in a retrofit project design?
Well, the thing is that that's so something to debate on, because a lot of process industries, they are reluctant to make changes to their current process layout. So one way to also to bring in intensified processes is to think of plug and play solutions. I mean, solutions that you can actually plug into process without making changes to the original process layout. For example, mobile solutions or decentralized solutions, or in a way that you can think of a plug and play solution.
Okay. Yeah. Okay.
Yeah.
And to finish our discussion, what is the major challenge that PI, process intensification, faces today? What do you think about those challenges?
I think for many process intensification alternatives, I mean, we need new materials, like new membranes, for example. We need to have design methods, how to design them. And, I mean, control of intensified operations is a big challenge, simply because of the loss in degrees of freedom. Basically, the controllability, I mean, becomes more challenging. And if you want to again look back at controllability of a process is an inherent property of the design. So again, back to the main point, we need to have a good design. Once we have a good design that basically is taken into account the conflicting trade-offs between design and control, basically then the control of intensified processes will be less challenging. But simply because of the loss in degrees of freedom, the control of and safe operation of intensified processes is another level of challenge. So I would say, again, in the same way that we intensify at the phenomenal level, task level, or unit operation level, we also have challenges at the phenomenal level to understand to obtain the properties, to have new functional material that can actually facilitate some of some of those intensification objectives. We need and when we talk about materials, I mean, it could be membranes, catalysts, different things, even insulators, or even different types of metals to build the equipment, or glass or plastic or whatever you say. And at the unit operation level, of course, I mean, how we come about this integration and design methods and control and addressing the safety issues is also another layer of challenge that needs to be addressed. So process intensification is a multi-scale problem, right?
Yeah,
and on the other hand, it also have different dimensions, right? So it has its economic dimension, it has its sustainability and environmental dimension, and it also has a societal perspective. How much the society is willing to pay for this increased sustainability?
Yeah,
right.
That's the question. Yeah, right. Professor Soheil, thank you so much.
Thank you very much, Ewerton, for having
your
me.
time. Yeah,
it
because
was excellent.
midnight in Copenhagen. Wow, it was amazing to have you here.
Yeah, it was also great.
I mean,
hope
see you soon.
Yeah. We all
ProBio Refine. What about ProBio Refine in Copenhagen this year? No more.
ProBio Refine in Denmark. We decided to actually not do it in 2020 because the situation is too uncertain. And we still love to meet our friends and colleagues from across the globe. So